And I see a large demand for lab developers out there. And there is, on the demand side, two main things that consultants really help. First is staff augmentation. Second, helping short-term projects. Let's make this point a little more real. We'll bring one of those companies here to the stage and learn more about what they do. Please welcome to the stage Santiago Orellana, President of DataLights, Miriam Lainez, a field application engineer for National Instruments, and Dean Diego Pelarona from Universidad, Politécnica de Salesiana, de Ecuador. Desculpa. I'm sorry for my Spanish, Dean.
Very good.
Good. Santiago, can you tell us a little bit about DataLights and what you guys do?
Of course. DataLights is the National Instruments distributor in Ecuador since 1995. In our early years, we focused on selling the products, but soon we realized that our clients needed much more technical advice to use that product efficiently. So we changed our approach from a commercial approach to a consultant value proposition. So we trained and certified our engineers in sales and in application development, and increased our proficiency, or technical proficiency, to the level of our clients needed to be.
That's very interesting. And I think you end up helping the Dean on an application. Could you talk about that, Dean Diego?
Sure. In academia, professors work to close the gap between the theory and the real-world problem and solutions. We teach in labs equipped with real instruments and devices which the students will see in your professional life. Where DataLights showed an example as to part of the introduced course in the wireless communication lab, where I have a PXE-RF in this lab with a vector analyzer, vector signal generator and analyzer. In the example, we generate an empty carrier in the same frequency of the radio station. We saw the effect. All radios in the classrooms got silenced. In another example, we generate our own audio message in FM and transmit, receive in the radio classroom. In another time, so when somebody proposed our students the idea to send the message indicate to our drivers that an ambulance is approached, we told it's very easy. We have already done it.
That's very interesting. So let's see if I got the concept right. The students were in the lab, and they generated an empty carrier. They killed the FM radios. And then in the lab, they did a carrier with some signal that started playing on the radio. The student in another place was talking about saving lives and have the ambulance generate signals. And then the student came and said, oh, we can do that. We've done it on the lab. That's a good story. Now I'm thinking PXI in ambulances. So how did you guys solve this problem, Santiago?
Well, actually, when the university purchased the laboratory, the only platform available was PXI. But by the time when the project came in, National Instruments had already a broad software-defined radio platform, and we chose USRP to implement the final prototype. So we changed some code. We added a code to switch from one frequency to another, and we drove in a real ambulance by Guayaquil at 3 a.m. in the morning to test the prototype and show it actually works.
Ooh.
Traffic in the city of Guayaquil not only affects the quality of life of its inhabitants, it can even take someone's life. We proposed the Radio Association of Ecuador and Clinic Association to create the Radio Ambulance. we installed in all ambulances software defined by radio and antenna. An integrated system that connects ambulances with all AM and FM radios.
Ambulancia acercándose, despeje el carril central. Ambulancia acercándose, despeje el carril central.
Within the range of 1 kilometer, ambulances were able to broadcast their own signal in order to pre-alert the vehicles onto yield. This simple device speeded up ambulance response time up to 40%. The Radio Ambulance. When interrupting radio saves lives.
This is a great example where you show students a little bit of the theory and help them apply that on the real world, and in the end you save lives. Thank you, Santiago. Thank you, Diego.
Thank you.
Sorry for the name. Thank you, Miriam.
Okay.